Hello everyone, in this tutorial I'm going to show you how to simulate a underwater explosion on a ship structure. So as you can see here in this geometry, we're going to have the acoustic domain, which is going to be our sea, and this is going to be a ship structure which is located in the middle. It's very small in comparison to the domain. And for a ship structure, we're going to use aluminium, and we're going to use a ductile and shear damage model. And for water, we're going to use acoustic domain. And as you can see here in the results section, when the explosion happened and how these explosion waves reach to the sea surface, and it would damage the structure. So for this tutorial, what you need information. You need the information about acoustic in general, and there is a video about this that you can watch. It is a theory about on-deck charge, and also there is another video about ductile and shear damage that you should definitely watch those one as well. So you would have information about input parameters. So if you're ready, let's do this one in Abaqus. Now I'm going to show you how to simulate an underwater explosion on a ship structure. Again, similar to the previous tutorial, I've modeled the geometry in SolidWorks software and saved it in a step format. You can download it from the resources section under this tutorial in Udemy. Then save the file in one of your drive, not on the desktop, and then go to File, Import, Part, and then as you can see we have two files, domain and ship structure. So first bring a domain. Keep the parameter as it is, click on OK, and then do exactly the same thing, import, part, ship structure. Make sure that you change the filter to a step so you can actually see your file. Click on OK, and then bring the second one. So this is a very simple ship structure. It's not accurate, but it's good enough for this example. So if I go to here to domain, as you can see, we have a one pieces domain, which is going to be our water. And if I go to mesh section, you would see that the color is brown, which means that we are not going to be able to apply a structure mesh to this one. In order to avoid that, what we can do basically, we can create some partition by clicking on this one, partition, point and normal. I'm going to select this one and this, create partition, this point, and select this one, and then again point normal, this point, and this point, this line, create partition. And then we need to have one as a partition in the middle as well. So what I'm going to do, I'm going to bring a one data component XY, because as you can see this XY is going to be located in the middle, offset 0, and then go here to the second one, select everything, click on done, and select this plane, create partition. So as you can see now it's in a green color, which means that we can apply a structure mesh to this one. So go back to part. What I'm going to do, I'm going to create some surface set for both domain and also ship structure, because that would help us when we want to apply a constraint, or we want to define any type of surface contact, tie, or anything else. So let's do it like this. Go to tools and then go to surface, create, and change the name here, water surface. Click on continue, hold the control, hold the shift, and select all these 6 faces. Click on done, and then go back to ship structure this time, and then now I'm going to select the bottom surface. So I'm going to go tools, surface, create, and this is going to be let's say ship surface. Click on continue, select this one, click on done. So now we have this one as well. Then go to property. Here we're going to create a material property for ship structure and also domain. I'm going to start with the domain, so I'm going to call a name domain, and first thing we need to add the density, which is going to be 1000, and then from here I'm going to add the acoustic medium, and the bulk modulus, if you go to Excel file that you can download from the resources section under this tutorial, if you go to the acoustic tab, we have a data here. So acoustic medium bulk modulus is 2.2 E9, so 2.2 E9, and then click on OK, and then create a section for this one, call it domain solid homogeneous continue, OK, and assign this one to this, click on OK, and done. And then I'm going to go to the ship structure. For a ship structure, I'm going to create a material property again. I'm going to call this one, for instance, let's make it out of aluminium, and then general density 2850. For elastic modulus, I'm going to add 70 E9, Poisson ratio 0.3, and then we can add the plastic information as well. We can activate a use strain rate dependent data, so this data will change based on the strain rate. Again, if you go to the Excel file and aluminium tab here, here you can find this data. So this is going to be our plastic deformation data. So I'm going to copy this one and paste it here. And then I'm going to also add the damage data, so damage for ductile damage. And from here, I'm going to add this, copy this, and paste it here. And also we can add the damage evaluation data as well. For instance, let's say 0.005, which means that after 5 millimeter of displacement, the damage will evolve in our material. Click on OK, and then I'm going to do the same thing for shear damage. I'm going to add the shear damage as well. Go to Excel file, and then from here you can select the data for shear damage. Copy this one and paste it here. And then also we need to add this KS, which is the material constant for aluminium, that this value is 0.3. And also same thing, damage evaluation, displacement of, I'm going to say 0.05, and then click on OK, and then OK, create a section for this one, aluminium solid homogeneous continue, select the aluminium, and then assign this one to this, click on done, select the aluminium, and OK. So now we have a material for both of them. Then go to assembly, add a domain first, and then add the ship structure and click on OK. So as you can see, ship structure is exactly located on a 0 point, so there is a perfect contact, we don't need to move it. But if you model your geometry in a way that this one goes inside the domain, you need to make sure that there is a normal contact. If your geometry goes inside the domain, then you need to use the method that we used in the previous tutorial. So you need to subtract your model from the domain. And make sure that to make your domain quite big, so the wall wouldn't affect the result, because I mean in reality ship in comparison to sea is exactly like this, like the ship is going to be very small in comparison to the size of the sea and ocean. So here we don't have to do anything, it's perfectly all the parts are perfectly located in a correct location. Then go to step, we're going to create a step for this one, so I'm going to select a dynamic explicit, continue, and then make this one for instance 0.05, and click on OK. And then from here I'm going to edit this one, and then make this one for instance 200. And then from failure fracture I'm going to add shear damage and also damage initiation criteria. And from the acoustic I'm going to add both of them, acoustic pressure, acoustic absolute pressure. And from state I'm going to add the status state, which is the if we have any elements, damage element, software would remove them. Click on OK, dismiss this one, and then go to interaction section. So now in interaction we need to define the explosion and the location of the explosive material. So in order to do that, first make this one height so we can see inside, And then I'm going to first create a interaction property for them. The interaction property type is going to be incident wave. Click on continue, and the definition is going to be spherical, and propagation mode is going to be undex charge. And now we need to provide this data. So this is going to be 1500, the speed of sound in the fluid, which is water in this case, and fluid density is 1000. And then we need to provide this one undex charge physical. You can find this data in this Excel file again. So this is 1.27. 1.27, this is gravity 9.8, pressure 1E5, and flow drag coefficient 0.25. Then go to the material. This section is for explosive material. So we have again data in this Excel 5. So this first one is 5.21 E7, and the second one is 9.95 E minus 7, and this is 0.186, 0.18, and again this one is KC 1.05 E9. Charge density is 1650, which is the density of the explosive material, and for charge mass, let's say 50 kilogram of explosive material, and for a time duration, let's say this one 0.02. This is the time that bubbles are created after explosion. So we're going to put it very small time here. So basically the result is changing a lot by changing this value. So make sure that if you're taking your data from anywhere, make sure that to record the time duration for a bubble model as well. So click on OK. Now we have an interaction property for that one. Now we need to create a source of the explosion. What I'm gonna do, I'm gonna add one point, and the first one is going to be 0.000. So this is exactly located underneath of this ship structure, and then the second one is going to be here at the bottom of the sea. So I'm going to say 0 minus 100 and 0. So it's going to be exactly here. Then I'm going to make this point reference point. So this one. And then what we can do, we can go to here, create interaction, and select the incident wave, and then select the source, which is going to be this. And then we need to select the reference point as a standoff point, which is the distance between a explosive material and our structure, which is going to be this one. And then after that, we need to select the region or surface that is going to receive the explosion wave. So go to surface, and from surface select the ship structure that we just created for that one. So click on continue, and then here change the definition to undex, a reference magnitude 1, and then for normal, so as you can see, normal, this is y direction, so y is toward in a normal direction. So I'm going to make this one 0, 1, and 0, and initial depth of the water is 100, and then click on OK. Then we need to create a interaction for acoustic impedance as well, which is basically going to be the surfaces, like outside surfaces. So it's going to be this one, this one, this one, and these surfaces here. Okay, select everything and then select done, and the wall is going to be non-reflecting. If you remember, in the Cope-Eulerian Lagrangian model, we explained what is a non-reflecting, which means that once the explosive wave reaches this domain, it's going to leave the domain. So the type is going to be spherical, and the radius is going to be 100. Click on OK, and then I'm going to create a tie contact between this surface and also structure. So it's going to be tie select the surface master, go to surface, select the domain, water surface, click on OK, and then select the slave one. This time select the ship structure surface. If you activate the highlight, you would be able to see what you're selecting as well. Then click on continue, and here change this method to surface, because when basically is a surface contact, but because we use the acoustic medium, then you can't use the surface contact with acoustic medium. You need to use the tie, but here we can change the method to the surface contact, and also you can basically define the distance between these two, that in this case we can consider it as a 0. But then click on OK. Then go to load section. In load section, what we're gonna do, we need to apply a boundary condition for the domain. So I'm gonna only keep the domain, go to part instance, keep the domain, replace this one, and then create a boundary condition, go to initial step, select other, and then acoustic pressure, click on continue, dismiss this one, select everything, click on done, and make the acoustic magnitude 0, and then go here and deactivate this one. So when we start solving the problem, the acoustic pressure is 0, but then after that in a step 1 we deactivated that one, which means that the pressure can change in the step 1. So dismiss this one, then go to mesh. For a part, I'm gonna apply let's say 10 or 8. Yeah, this one is good. Assign a mesh, yes, and then go to ship structure. For this one, again, we can basically create a sections. So if you create a section here, all through here, and also at the bottom, then you need to create a section around these holes, basically circles, then you would be able to apply a structure mesh. But we don't really want to spend the time on that because you know how to do it. And so let's just make it simple and change a element shape to text, apply this one, and then from here assign a mesh to this one, make it 0.05, maybe 2, apply, and then assign a mesh, yes. If it takes a long time to mesh it, you can keep it as 0.05 by stopping it here, and then change the element C to 0.05. So we can have a mesh like this, but I guess this one is very fine, so let's change this one to probably 0.05, apply this, say yes, then OK, then assign a mesh. So I mean, this one is better because we don't want to really spend the time on solving this example. So now we have our domain, and click on this one to see everything, and we have our mesh here on a structure as well. Now you can go to element type here, select everything, click on done, and make sure that it's on explicit 3D stress, and then you can activate the element deletion as well. So if you have any damage, the element would be removed. Normally use default is the same thing as well, the element would be removed, but it's better to put it on yes here, and then go back to domain and also change the element type here as well. So this is going to be acoustic and explicit type. Click on OK, done, and go back to assemble. And now what I'm gonna do, I'm gonna go to file, and from I'm gonna go to model, edit attribute, and I'm gonna edit model 1. Here I'm gonna specify a acoustic wave formulation, and I'm gonna select the total wave. If you remember, we had two models, total wave and a scatter wave, that I explained in the theory videos. And total wave normally is better when you have basically a structure and you want to see a damage on a structure. So click on OK, and then from here click on this one, so you have everything on your model, and deactivate hide. And then from here you can create a job and call this one shim index ship number 2, click on continue, click on OK, and then submit this job. So I've run this model before. If you don't get any error, I'm going to show you the result in other model that I've already ran. So as you can see, there is no error. So I'm going to show you the result in the other model. So as you can see, the model is completed and the time is 0.05 here. I'm going to go to ship. Then let's go to the first step, and I'm going to activate this one and also activate a section cut. Let's first see the pull pressure. So if I increase the steps, you can see what will happen and how it would spread in our domain, and also we can see the absolute pull pressure as well. So actually this one is not changing that much. And then what we can see, actually we can see the damage on the structure. So if I go here as S, which is going to be a stress, and if I increase this step, you see that what will happen to our structure. And this is actually the particles that is separated from the main structure due to that impact. And as you can see, it just goes to the air like this. And then also we can see that, for instance, ductile damage, and also we can see a shear damage for this one. And also we can change the basically the way that we represent the result by going to here, activate this one, Z plane, and then go here, isosurface, change this one to pull pressure, and apply this one, and you can actually see the basically how the waves develop inside our domain. Okay, and also what you can do, you can just deactivate this one, activate a mesh, apply a mesh, and then as I mentioned before, you can just extract the pressure data for a specific point. For instance, I can go here, create ODB field output, and then unique nodal, and then I can select, for instance, this point here, click on done, and then click select the pull pressure and apply this one. And then as you can see, the pressure is high and then gradually goes toward 0. Yeah, that's everything for this tutorial. I hope you learned something about Ondex Charge and you will be able to use it in your projects in future. Thank you so much for watching.